In technology, you have the ones who implement, but you also have the ones who invent, innovate, create. Zach Shelby is one of these trailblazers. You might know him as the co-founder of Edge Impulse, a great edge AI technology. But did you know that Zach was also at the inception of Microbit, this great IoT educational device? By retracing Zach's career, we will be retracing part of the IoT history. So let's go through that on this new episode of the IoT Show, which is sponsored by the IoT Stars, facilitating real conversations around IoT. And this one definitely is a real conversation about IoT. And if you like this episode, do not forget to subscribe as usual, get notified for the new episodes, put a like, and leave a comment. Hey everyone, this is the IoT Show. I'm Olivier, your host. Today we have Zach Shelby with us to talk about, well, you'll see, some history. We'll do some traveling down memory lane. The idea here is to retrace what happened with embedded IoT, edge AI, all the way until today, with someone who I personally think is a trailblazer in technology. Zach, how are you?
Hey, I'm doing great. Great to be here.
Well, thanks for your time. Thanks for joining us today. For those who don't know you, can you tell us what are you doing today? And then we'll go through, your history and where you're coming from.
Sure. So I'm Zach Shelby. I'm known as the co-founder and CEO of Edge Impulse. So I've been building a platform that helps all developers, all the way from students to professionals who really know AI deeply, through to factory floor technicians. So democratizing AI for them, enabling them to use the data they have access to. So real data from the field, sensor fusion, so all types of different types of um, accelerometer, magnetometer type sensors, to audio, human speech, and machine sounds, all the way through to complex computer vision, and helping them create their own AI workloads and then deploying those on edge compute, all the way from MCUs through to GPUs. So I've been doing that for the last 6 years.
Okay, yeah, and you had a life before that, and a lot of it was related to IoT and embedded. And so before we get into that history of yours, I have a quick question for you. What is the device, the IoT slash embedded device that has marked you the most, whether because it was the most innovative you've seen or surprising or interesting or useful, or on the contrary, what's the dumbest you've ever seen?
Well, I have two different kinds of favorites, if I can have two.
Yeah,
So the one that, of course, really inspired me and inspired a lot of children around the world is, of course, this one.
yeah,
You recognize this,
microbit.
the BBC microbit.
Yeah,
So this is something that ARM was involved in back in the day, helped start this together with the BBC and Microsoft. So
hmm,
Microsoft was involved as well. And I worked together with an awesome engineer from our team at ARM, Johnny Austin. And together with Johnny, we actually created a foundation around this. So the Microbit Foundation, based in the UK, was co-founded by Johnny and I. And we helped build these and get them in the hands of millions and millions of children, UK and all around the world. So this is a very cool device, right? From IoT, kind of, democratizing IoT down to the middle school and elementary level
interesting.
kids,
And
right? So think of
that was
Arduino,
almost 10 years
Arduino,
ago,
right?
right?
Like that was about 10 years ago, yes,
Yeah,
when we
so
started that.
these kids are now in college.
They are. And actually, one kid had an inspiring story. So we started this up. Johnny and I, got it kicked off. We kind of turned a project that had started as really just a project between these entities into a real nonprofit, right, where we could go operate this thing independently. And I met a boy. His name is Ross. He was 15 at the time, and he had just been volunteering, building cool stuff around the microbit, because you can build your own, MicroPython and block-based applications for this and deploy them. And he was just an active volunteer at 15. And so we invited him to the Bet Show, got him on stage, and I had a fireside chat with Ross, because I was kind of curious, like, how does he perceive, growing into this technology, and what kind of things he can do, and what is it that he wants to do in the future. And so we got to know him, and later he became an intern at the Microbit Foundation. He helped build the Microbit webpage. If you go to microbit.org, Ross and I actually built that webpage ourselves. It's all static,
That's crazy.
doing
Yeah.
some cool static stuff. Um, and then he went on to go to college, started doing some AI stuff. Jan and I, when we were founding Microbit, we got wind of that. We saw what he was building. He was building some really cool online like AI education tooling. Um, we hired him in as an intern again, second time around. So he came to work as an intern at Edge Impulse, and now he's one of our star engineers at Edge Impulse in our studio team. So all the front-facing stuff that you see at Edge Impulse, the graphical stuff,
Mhm.
Ross is one of our engineering team members. So he went from 15-year-old kid working on this platform just as a volunteer to having a couple different jobs in the industry, going to college and then becoming a professional. So
Nice.
for sure, right, this kind of thing really does. People grow up, right? They start out as kids with these platforms, and then they go to
Mhm.
college, they learn more tooling, right? And then they end up becoming professional engineers. So we
Yeah.
should never underestimate, right, what it means to get this kind of technology in the hands of young people, both
Yeah.
at kind of the the primary, elementary, middle school
Definitely.
level, and then all the way through the university.
Definitely.
So that's
So
an
so that's your first type of favorite IoT device, the inspiring one, the one that generates careers and lead people
yeah.
to work in this industry. What is the second one?
So the second one is about the environment, right? I really care about tech for good. I want to see the technology that we're building, like we saw with the microbit, right? Getting in the hands of
Mm.
education. I want to see technology change the world in a good way, right? I guess I'm an optimist. So one that caught my eye recently was a startup based out of California by three young women
Mhm.
that created a radar detection system for lithium ion batteries hitting the waste cycle and causing
Mm.
explosions, fires, leaks, etc. This company is called Nextera Tech. Very cool company, right? They kind of got a hold of, wow, if we could solve this problem, how can we combine like the newest sensors doing radar with Edge AI using Edge Impulse? And so we've seen them build this startup, get funding, and start to bring it to market. So that's really inspiring how young engineers can kind of take combinations of technology that I wouldn't have thought of. I didn't know that you could
Yeah. Yeah.
detect lithium ion batteries in garbage cans, right, using radar.
That's fascinating. That's fascinating. That makes me think of a story when I was at Microsoft. It was the owner of the Imagine Cup competition for embedded development. So Imagine Cup was this kind of like Olympics of software development organized by Microsoft and inviting students across the world to compete for the best project. And it was super interesting because there were these local competitions, and then all the winners of the local ones were all invited by Microsoft in some place. Like we went
Hmm.
to Romania, went to Egypt one time, and one of the projects that really struck me was I'm really like I was positively shocked was this Korean team building a what was it exactly? It's like a larva harvesting machine to be used in Africa to produce protein for families in a self and sustainable way. But they thought about not just a device that was all about monitoring humidity and other things in that larva, breeding machine, but also they thought about a business model where these families in Africa and little village could just feed themselves to start with, and then they could duplicate, replicate, and they can start feeding their village and start making money out of that, and then grow, there was a business model as well for facilitating the provisioning of parts for building the thing was like there was a kid that was more business, kid more marketing, kid more embedded development, and I was like, that's it. That's the way you do IoT right. That was pretty impressive.
Oftentimes, the business model is the hard one to crack. People don't really realize in these teams building something new is, yeah, great, you built the technology. How do you build a business model that's sustainable, investable, right?
Exactly.
Scalable? Super, super
Exactly.
hard.
Exactly. Zach, that helps me rewinding the story here, right? Talking about business models and how do you make something, you have innovation on one hand, you have an interesting concept, you try it, you want to test it. Like as technologists, we like that. We are engineers, we like to, test things and experiment. But how did you come to realize that embedded slash IoT was a thing? You talked about
Hmm.
microbit and you went in that direction. So how did you realize this was something that was to be?
Yeah, I guess for me it was really just like a cross section of the things that I was interested when I was young. So I grew up as an internet engineer, an internet hacker, electronics hacker. I was in the back room of my parents' house in Michigan, where I grew up, very far north, so Michigan near the Canadian border.
Yeah.
Um, and I like to play with electronics. I like to build things, right, that do like little control logic. And at the same time, I was really interested in the internet, right? This was the 1990s, early 1990s, late 80s,
Mhm.
when the internet was something very new, right? It wasn't something everybody had access to even. I was like using a modem to dial into the university network to try to get access to Gopher, right?
Mhm.
For those of you that remember what Gopher is. And I was running a BBS at my mom's house with like three phone lines. She's like, "Why do you need three phone lines? You're not doing dealing drugs." No, 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 mom. This is a BBS. We're playing online games, and so it was like the very early days of the internet. So that got me really inspired. So when I started to become a programmer and then went to school to get my electrical engineering degree, I kind of wanted to combine these worlds, right? This world of the internet, and how do we communicate between things and people um, with electronics and electrical engineering. And so for me, it became this kind of like this combination. And it was hard to find, right? In Michigan, I actually studied computer engineering. So
Mhm.
processor design, processor architecture was my studies, did some DSP, but they didn't have communications at Michigan Tech. So I ended up moving to Finland when I was 19 and going to the university that Nokia was basically born from, the
Mhm.
University of Oulu, up north in Finland. This is where all the kind of wideband CDMA early communication stuff happened. And they had an amazing communications program, right? One of the best in the world, really inspiring stuff. And so I had to kind of do this and combine two schools halfway across the world in order to get what I wanted, which was it ended up becoming the Internet of Things. But back then it was just two weird ends of electrical engineering that I was interested in, right?
Yeah.
Embedded control and systems and electronics, and then the internet. And how could we combine these two things together had always been something I was kind of more and more becoming obsessed with. So,
Yeah. But is it
so I
fair,
was,
Zach? Let me ask you that. So you were obsessed with it because it was, an interest of yours, a passion. But is it also fair to say that you could see that it was going somewhere? Because like you did all. You're passionate. That's obvious. The question though is that to be an entrepreneur and be where you are at today, where you created Edge and Pulse and we might talk about that a little bit, is being acquired by Qualcomm. And so you had a vision as well of a successful business around these technologies, right?
some of it's luck, to be honest, right? You can be passionate and obsessed with sometimes the wrong thing, right? Like at the wrong time. But if you're onto something that's up and coming, right, you
Hmm.
usually can't go wrong. So in my case, right, I could see and I had vision of how useful the internet was becoming, right? We were at that very early stage of the late 90s where browsers started to become useful. Information was available, right? We could see that it was
Hmm.
helping democratize the world. There was all these really positive things around the internet. And then we had these machines, right, that I was always interested in, robots and weather stations and control systems and street lights, and the world is full of machines. Like, why shouldn't those two things be combined together somehow, right? So that we can communicate and control the machines.
Yeah.
So I kind of just saw these two areas being very useful. So one of my first projects as a young engineer, so I ended up I went from Michigan to Oulu in Finland when I was 19. I ended up getting a job there at the Finnish National Research Institute, and they set up a wireless research group. Um, led by a really interesting professor, very much ahead of his time. And that kind of gave me the platform and the freedom and the resources to go start doing some of this. So one of my first projects was putting a Vaisala weather station. So Vaisala is one of the leading weather equipment, weather station makers in the
Yeah.
world,
Okay.
Finnish, very big into climate and sustainability. So Vaisala donated a weather station, really pro stuff, right? Expensive weather station. We put it on the roof of the building. And I developed one of the first embedded Linux, one of these DIP embedded Linux. It was actually running MIPS processor at first
Hmm.
with an IPv6 stack connected to Ethernet.
Okay.
And I ran a little web server over IPv6 in those days. This was 99, 2000, and put that up on the roof. So we made this like internet connected weather station. And the interesting thing is that thing is still running. The processor's been changed. It's still embedded Linux. They upgraded the processor at some point, but it's the same program that's been running on there since the early 2000s.
Well,
And
if
it's
it works,
logging
if it's not broken, don't fix it, right?
it's logging weather. You can look at it. It's the YLab weather station in Oulu. It's been
Mhm.
logging weather for the last 25 years. So I actually heard from my wife, who's a geographer, that biology and geography researchers in northern Finland, they use the data from that weather station because it's one of the only sources of continuous data for that area, like physical sensing continuous data for weather that's continuous for that long of a period with the same sensor, right? So
Wow.
it's been calibrated. So I was like, wow, that thing's still running. I didn't even know, right? My wife told me the weather station's still running. So that was my first project, combining those two worlds of internet and sensing and electronics. That kind of got me started on my career from there.
Nice, nice. And yeah, I was thinking, your wife cannot get away from you, right? You're everywhere, coming from work as well with data from that device. There's remote there. So I made that joke about the fact that yeah, you don't fix something that's working. IoT and embedded devices are renowned for having a long life cycle, right? So they will be out there, especially in industries like manufacturing. They are expected to be there a long time. And so you build robust technology like this embedded Linux core that you've been developing
Yeah.
for that weather station. And it begs the question, why do we need, or when do you think we started thinking about bringing more intelligence, machine learning models that were created, and
Yeah.
run onto servers and sometimes farms or servers? And when did you start thinking about, hey, how about we start shrinking these models to run them on these embedded devices, and why? Why do you think we wanted you work in communications? The devices could communicate their data, and machine learning could happen somewhere we had all these computer resources. So what triggered that inception of TinyML, and the work you did with Edge Impulse?
Well, my first startup came out of that wireless internet stuff I did back in the early 2000s. So we started one of the first IoT stack companies called SensiNode back then.
Mm-hmm.
And we'd worked so hard to build all this device management, remote internet communications, IPv6 stacks over any kind of wireless, both mesh and cellular, Bluetooth low energy. And the outcome was a little disappointing for me. Oh, now we're measuring temperature every 10 minutes and sending it to the cloud. And then it sits in some cloud data lake, data ocean.
Mm-hmm.
Who's doing something with it? What is it used for? Do we actually get that much intelligence out of all of this IoT data that we're just logging? So we kind of created this massive data logging machine for IoT devices without really getting that much more intelligence out of the sensing that's happening in the edge. And then we're also filtering, right? Because we're measuring some sensor one time every 10 minutes or every hour. We're doing a lot of averaging, thresholding. We're losing tons of data, right? We're losing a lot of the small fine things that are happening there on the edge. And so I felt like something's missing. And so years went past then, right? We were acquired by ARM. I started working on the wider ARM ecosystem, and I got involved with DevRel, just like you have in your career, right? I got involved with DevRel. I ran a DevRel team at ARM, doing a bunch of open source stuff around IoT. And we happened to have a guy. So Jan and I ran that team. We had a guy that worked for us out of Taiwan. And he just happened to have a background of robotics and AI. He'd been a like kind of early AI hacker, building these neural network systems, really like hand built things for big robotics, right? He was running these on big compute. And he just then joined our team to work on DevRel for microcontrollers. And he came to us one day and was like, hey, I've been working on this thing. I think we can make like a really easy way to build these neural networks so we can compile them down for Cortex M and Cortex A without any fancy extra tooling, right? Doing it like really down to the bare metal. And Jan and I were like, you can't do that. we're like, "Yeah, this isn't possible." And he was like, I'll show you, right? It's like, it's not as black magic as they say. It's just the tooling's not correct. And so this was about 10 years ago that this came in front of us. And I think the thing that you have to remember, like, yeah, when you're the early young researcher, right? As I was in the early days of IoT, right? I was the researcher pushing the bounds of what we can do with protocols. How do we go from big IP to something that's small, right? 6LoWPAN. How do we go from big security to something that's small? Again, we shrunk TLS down to DTLS. How do we go take the web, right, and compress it down for small sensor data? We did the standards for that. So I was that researcher at the time, and I kind of had that vision because I was so down in the details. And I had people who trusted me, that I knew I was onto something, and gave me the space and resources to go just go do it. And that's what I realized when I heard this conversation going on around this crazy ML stuff from microcontrollers, that this young guy, he's onto something, right?
Mhm.
He's seen these things. He knows something can be done here. Doesn't quite know how to do it or where we should go next, but he needs some space and resources to work on it. So I gave it to him. So now at that point, I was the leader of that team. I could give him the space, some resources to go work on this project, and that became one of the first open source projects for machine learning model compilation on microcontrollers. And this was just before the time of TinyML. And we then helped to get the TinyML Foundation set up with Evgeny
Mhm.
and others back in those days. So it was just luck, right? I happened to be in a team that had the kind of talent and the space to work on something new like this, right? We were set
Yeah.
up to work on cool open source projects for Cortex M and Cortex A, and we decided that this was a cool project, right? Let's incubate it.
Yeah.
Um, the funny story is, we thought it sucked. It was so hard to use, and machine learning was so difficult at that time. Like, we did it,
Mhm.
it was cool, right? You could compile an MNIST model down for Cortex-M and deploy it on a microcontroller, and it kind of worked. But what does an MNIST model do, right? You have a fake image, you store it in Flash, you classify that fake image, right, from Flash, and give an answer that, oh yeah, it was a shoe. It wasn't a real model, right? There was no real use case. There was no real sensor data coming
Yeah.
through. It was super difficult for anybody to compile a model, right, or even train a model for this stuff, right? Like, the tooling was made for researchers. So Jan and I actually got pretty frustrated in the sense that, wow, this is so hard to use. This is never going to work for industry. That was
Mhm.
actually our frustration level. We almost buried the project. We got pretty close to just saying, you know what? Let's go work on other stuff. We had a bunch of other things on our table that we wanted to work on. This thing is just too hard. Great. The open source project is there. Just leave it. And then we realized over sushi and sake one night near my place in California, we were like, why is this so hard, right? Like, why is this ML stuff so difficult? And it came to us finally that, wow, it's a developer persona mismatch. The developers in ML, right? They're ML researchers. They're writing papers for ML conferences. They don't care about other developers. They're just creating these weird Python tooling
Mhm.
stacks for themselves, right? To write a paper and then throw away the code and then write another paper with new code. And they didn't care about usability. They didn't care about engineers, right, from industries using this stuff to build real things. That wasn't their target persona. And Jan and I were like, well, we know industrial embedded engineers, right? Like, that is our persona, right? That's what we've always done. Maybe we could help solve the problem. So that's how this Edge Impulse was formed, right? When we'd gone and done the open source work, we kind of incubated the idea, and it sucked. Sometimes the best startup ideas are because something's broken
Mhm.
and you've had, like, personally had painful experiences with it. And that's kind of where we are at. Like, so
Yeah.
painful that somebody has to fix this. And we were just passionate about it. So we felt like, hey, we could go fix this. And so we formed Edge Impulse for this purpose. Like, let's do ML, but let's not make it suck, right? Let's do ML and make a developer experience that's really beautiful, that people can go build custom stuff, right,
Yeah.
themselves and do it quickly.
Awesome. That's great. I'm almost tempted to ask you, what is it that you're going to work on next? But I know what you're working on, continuously, on Edge and Pulse and making it, as we are saying, like you were saying, it's changed, but it's not changed, right? It's all the
Mhm.
same. And I like that a lot. So I'll get to that, but I wanted to ask you one more question. Based on you're saying it's luck. Yes, this part of that is luck, but you also said, you say it in your own words. I had this vision. You're a visionary, and you see things coming, and that's what some people are able to do out there, and that we look up to, and we just like say, hey, if they are on this, that means there's something. I'm sure there's tons of your ideas you threw away, like you almost did with TinyML, because you have so many coming up. But you stick on some of them, and some of them happen to work and be successful in their own way. And so I'm curious to know where you see things going. We are in a very interesting, to say the least, situation these days from geopolitical perspective, from how the market is evolving, how big companies are getting involved in pretty much everything. You have big conglomerates, big companies that do it all. Where do you see things going? What is maybe not the next thing you'll focus on, but where do you see this industry that we are all working in, IoT, Edge AI, and so on, going in the next few years? What's your vision for that?
Well, I'm going to be continuing to expand the mission for Edge Impulse, right? So I continue to lead Edge Impulse as part of Qualcomm, and we're only going to have the resources to do more, which is really exciting. So
Mhm.
for the short term, right, that's what I'm going to continue doing. Um, I'll give you a little preview hint of something I'm working on, just a little secret. I'm also starting a nonprofit foundation. We
Okay.
can talk about that another time. That's something else I'm passionate about
Okay.
is
Yeah.
education and entrepreneurship for young people. And so we'll talk about that later when I have something more to share. But it's something else that I want to start working on again because I did that before with the Microbit Foundation.
Yeah.
And as far as the technology around IoT and machine learning goes, I think there's two things, right? One, platforms are pretty well played out. You shouldn't be building another platform. We have enough platform tooling to work with.
Yeah. Please don't.
No, that's not the area you're going to go and do a lot of innovation in. Instead, I think there's a ton of space to grow in open source. So I think doing more in open source, that's actually one great answer for what's happening geopolitically at the moment. Like
Mhm.
open source and also nice SaaS services that are easily used from anywhere. I think they transcend borders really nicely. And we've seen that with DeepSeek, for example, right? Coming out of the Chinese ecosystem, hitting the US ecosystem, going back again. We've got model architectures people are working on and sharing on Hugging Face, right? Huge shout out to Hugging Face. I think they're doing a great job at helping people share what's happening.
Mhm.
We're doing the same on Edge Impulse, right? We're also a community for sharing not just models, but whole data sets and whole projects that people work on. So I think this community of sharing what's happening is something that really helps diffuse some of the geopolitical situation. From a technology point of view, tons of interesting stuff happening in Gen AI, and
Mhm.
I think it will continue to get more interesting. But it's not the Gen AI that you think it is, right? It's not just the let's throw a bunch of stuff to the cloud and then some magical open AI black box is going to go give you an answer, right? That's kind of lazy use of Gen AI. The interesting use of Gen AI right now is that these models are getting more efficient and smaller to the point that we can package up more domain centric snapshots or distilled models of, for example, vision language models. VLMs are becoming already now useful for industries. So we just at Embedded World deployed an 8 billion parameter VLM that had just been released the day before from the Qualcomm research team. Uh, onto an edge device. And we built that into an edge impulse experience then. And that really kind of opened my eyes that, wow, this stuff is becoming useful. Now we can use VLMs to do like detailed object vision analysis. So not just, oh, we detected a car. So we have a lot of customers in things like car washes and vehicle detection in lots of different situations. Before we could just say, hey, here's a car. Maybe we
Yeah.
could get the license plate number. But with this VLM, it's really amazing, right? We could, as part of the development experience, say, all right, here's our object detector to go get that car. Then, hey, what color is this car? What's the make? What's the model? What kind of rims does it have? Does it have damage? What's written on the side of the car, right? Because something has
Mhm.
like ABC Plumbing Company. That's really
Yeah.
hard. There's a lot of different fonts, and so it could even tell us that. Does it have a roof rack, right? You're not supposed to go with a roof rack in the car wash, right? Does it have a ski box, right? All kinds of information about that we could extract from the image and then put into a JSON structure. Very nicely formatted with ABC options, easy for a machine to go make use of in an IoT system. We were able to demonstrate that at Embedded World. And I think that kind of gives you a little bit of a peek of where Gen AI is going right now. Like we can use
Mhm.
this as part of building an industrial system, but we can make it something that's testable, right? End to end, we can control the entire thing. What kind of image we're capturing, what do we send to it, what we're extracting. And so we're doing things like building test infrastructure around that now. So you can also test for that, right? How accurate is it? And control how that's used. So we're going to see a lot more of that coming out of Gen AI that's like directly applicable to edge.
Nice, nice, super interesting, Zach. So, last question for you, Zach. If you were to talk to young Zach Shelby, the one just out of school or just like tinkering with things that they're passionate about, what would you tell him? What would you tell to someone who is just out of school or still in school or planning not to go to school, in terms of go play with that, think about this, because that's where things are, right? And what would you tell yourself, basically?
Yeah, well, I think the important thing is that you get a toolkit. And there's two types of toolkits, right? There's the technical toolkit that you kind of understand how things work in the world. Go deeper, right? Go under the hood of what's really happening underneath
Mhm.
this stuff. So kind of take control of the tech stack yourself. You need to get deeper. Like I started out my career as a programmer. I was doing Visual Basic and SQL databases at like 18, 19. I didn't have an education. I just
Mhm.
learned myself. I actually moved out to Seattle for 1 year, started working as a contract programmer, and I didn't like it. I didn't like it. I was like the lowest of the low, working on boring stuff, some billing systems. I was like, I don't see a future. I don't understand how the stuff is working on the inside. Microsoft's never going to hire me. I'm just a coder. I want more. I want to know how this stuff really works, right? So go deeper, go get education, right? I actually think education does matter. We have a lot of people talking today like education doesn't matter. It's not true. Education does matter. It
Mhm.
gives you a chance to go work with the people that can guide you to go deeper, right? What's really happening under the hood. Because it's
Yeah.
the stuff under the hood that lets you build the next thing, right? Like that's what we
Yeah.
did with IoT. We took all the pieces that we wanted from and we built it into something new that we had a vision for. And then the second thing I would say about education is that there's the networking side of it, right? Like that is really important for you as you start your career and you want to go do things, right? You want to go build bigger things. You have to know people, right? You have to know how things work. You have to know how big projects are run. You have to know how money works, right? How is funding working for these projects? Um, who are the other amazing engineering talents that you want to go work with, right? You need partners in crime to go build this stuff. I have never built any of these things alone. And I don't do that, right? I always work with somebody, a co-founder who's either more business than me or more technical than me, because alone it's a very lonely path to build this kind of things, right?
Yeah.
So you want to work with others, but you have to be able to find those other people. And so going into like a university kind of environment, that's where you meet those people, at least to start with. Later in your career, right, you've built up that network. But early on, it's a lot easier to start from university.
Yeah.
So there's a couple of the tips that I would
I
give
like
young
that.
people, like really
I
do
like that.
go get experience, right, through an
Yeah,
academic environment, and then find your passion, right? Find the thing that you really want to work on. Go
that
do
makes
the
sense.
research, right? Get involved with some research projects first, for example. I think academia is a great way to start. And then when you find that thing you're passionate about, go jump into it. And that's how we started our first startup. We were university researchers
Yeah.
working on IoT, right? And finally, we were like, why is nobody implementing any of this, right? Like we built it all and nobody cares, right? Not a single corporation is going to touch this stuff because it's too disruptive. So we're like, screw this. We're going to make our own startup. We're going to do open source. We're going to give it away. So everybody has to use it. That was like our master grant plan back in the day for IoT.
Nice.
It sort of worked out, just took 10 years longer. But that was a good starting point, right? Coming from that academic environment and then jumping into the project that we cared about.
Of that. One more thing I would add that you experience yourself when you say going to university, study, and so on. It doesn't have to be in the US if you're American. You can actually go
Oh, I
study
studied in
abroad.
Finland.
Exactly.
Yeah, I
Exactly. And
studied
vice
in
versa.
Finland, and that,
And vice versa. You need to go find that networking, that education, opening up your mind, traveling,
yep,
meeting people that might not be of the same culture and background, and that actually enriches you even more.
I agree with that. Yeah, my career would not have been the same if I wouldn't have gone to Finland and kind of found this wireless communications ecosystem and the resources around that. I would have done something totally different. Maybe I would have worked for IBM my entire career. Who knows? Like, it could have been really boring.
Sorry. Sorry.
Horrifying,
Awesome.
right? Like,
Yeah.
so
Zach,
yeah, don't be afraid to go follow your dreams and go wherever it takes you, right? There's no one place. It's very globalized now.
I love that. Thanks, Zach. This is you're an optimistic. I am too, and I think this is really eye opening and very insightful. Topics that we covered today. I appreciate your time today, everyone. Appreciate you logged in and watched this episode of the IoT Show. See you soon, Zach, as well. See you soon.
Thank you.